Hello teacher and everyone. So today my team is going to introduce our sensor and actuators project. The name of this project is Agricultural Products Drying Support System. My team consists of two members. My name is Ngô Văn Môn and my teammate, his name is Lê Đức Ngọc Anh. First of all, I will present about overview about drying agricultural products. About principle of drying agricultural products, we know that in order for agricultural products to direct sunlight, agricultural products we know the amount of water we can reach the dry state, adjustment in agricultural process. Therefore, factors affecting the drying process. We know that there are weather, time, children. It's easily to realize the drying agricultural products face many difficulties that need to solve. First, the weather changes electrically, so difficulty in storing agricultural products in bad weather conditions. Second, agricultural products need to be flipped regularly, so need people flip agricultural products regularly. Finally, agricultural products need to be determined suitable time to dry. So difficult for less experienced people to know drying time scientifically. Therefore, we choose the project to solve this problem because by solution apply sensors and microcontrollers, we can easily solve the given problem such as automatically closing, tarpaulin and backwater, automatically flipping agricultural products, and monitoring drying process by temperature and humidity sensor. Next, I am going to introduce about our project solution description diagram. You guys can see that the signal from the sensor are the inputs that are processed by the microcontrollers to give output signals to the LCD screen and the motor. So our project has a solution such as displaying temperature and humidity on LCD, automatically closing tarpaulin by motor, automatically flipping by motor. In addition, our system also has an upper system to control the tarpaulin and flipping motor, without depending on the signal from the sensor. Alright, next, my teammate Pháp Anh he going to present about setting and calculating the required equipment.
Okay, now I will talking about selecting and calculating the required equipment. First, we will talking about sensor. Here we have the photo detector sensor. It will help us to detect the light around the system. About specification, we will take care about operating volt. It's from 3.3 to 5 volt. It consists of 4 pins. with two power supply pin and two signal pin. It can be send the signal of analog signal or digital signal. About dimension, you can see in the slide. Then now we have the range sensor. It is able to detect where the weather is rain or not. It have the play here, and we the play here, and we can detect the rain depend on display. About specification, and it uses the voltage of 5 volts. The consumption current is smaller than 20 milliampere. The output signal is analog, or you can have the signal of the digital. That about the dimension, we have you can see the dimension here. About the temperature and humidity sensor, it will help us to measure the temperature and humidity quantity. About the specification, the operating volt usually is 5 volt. The communication standard is have the GTL or 1Y. About the humidity measurement range is from 20% to 80%, and the error is 5%. About the temperature measurement range is from 0 to 50 degree, and the error is 2 degree. The maximum sampling frequency is 1 Hz. About dimension and form, you can see in the picture and the slide here. Then we will consider about the microcontroller. The microcontroller in this model we use is Arduino Uno. It will control all the device of the system, and it receives the signal from the sensor, then processing, and then it will send the output signal to the actuator. To display the temperature and humidity information, we will use the LCD. The communication of the LCD is used is I2C. To creating the mechanical movement of the turbulent system on the flip system, we will use some driver here. First, we have the clicker. Its name is L298N motor driver. It will control all the driver to creating the mechanical movement. Then we have the motor solid and the battery. About the active principle for actuator, we consider about the turbulent system. The turbulent will automatically open when it is not rain, or the humidity is below than 70%, or the line around the system is bright. And yeah, if the turbulent, if the weather is not is rains, or the humidity is greater than or equal 70, or is it the light around the system is dark, the polling will close. About the flipping system, is the have the running bar to flip the agricultural product will automatically move along the drying surface and continue to move in the opposite direction. After 10 seconds, when the tarpaulin stay is open. When the tarpaulin stay is open, the running bar will automatically not move along the drying surface to save the consumed electric energy. Then here we have the internet set. It helps us to contact with the system. In this model, we use the button to control the system. We call that is hand control. About the active principle for controlling motor, we will controlling use three three button to control the system. By control the tarpaulin system, the flip system, and we can change the state from automatic to hand control. After um, we have the information about the device. Now we will modeling for agricultural product drying support system. Okay, now you can see here. Okay, now we will see about demo of mechanical system. You see that here we have the rectangular iron frame. Uh, below above here we have the coupling system. Here we have the movement system, and below here we have the flip system. This is all of the mechanical system we design. Okay, then we will see about the electrical keycloth diagram. Here we have the microcontrol. Here is the actuator. Here the motor to control the coupling system, and here is flip system. And all of here is the sensor. Yeah, and here the LCD. After we modeling the product, now we will design the product, and then we have the result. You can see here is the overview about the system. To understand how our system works, let's see the video. Hello teacher and everybody in my class. Today I will talking about the function of agricultural product drying support system. First, I will introduce about all the components of the system. The most important here is the simulate the system. This consists of the rectangular iron frame. Below here is the flip system. It consists of the running bar. We have to flip the agricultural product. Above here is the tarpaulin system, which have the tarpaulin cover the product. It prevents from being wet and keeping the quality of the product. About the movement, we have the movement system consists of the rope moving around here with connecting with the pulley, and the pulley connecting with the motor, which creating the movement. Here we have the kickers which supporting to control the movement. Here is the battery. About the sensor, we have the photo detector sensor. Here is run sensor, and here the, the temperature and humidity sensor. Here we have the interact set. It will help us to interact with the system. Here we have the microcontrol, which the name is Arduino Uno. It is the brain of the system. It controls all the device of the system. Here is the LCD. It shows all the information about temperature and humidity.
Have a look. Our system has the automatic flipping agriculture products function of the running bar. You can see every 10 seconds the running bar will move in the opposite direction. Let's think about the toppling system. When encountering bad weather such as rain or low humidity, the toppling will automatically be cold. So we will simulate that. You can see the toppling was cold. When the toppling is cold, the running bar does not work to save energy. When it is not rain, you can see the toppling is opened. The flipping system is on. In addition, when the humidity greater than or equals 17%, the toppling will automatically be closed. But at the moment, the humidity is smaller than 70%. So, of course, the state toppling is still open. When it is dark, the toppling will automatically be closed. When the toppling is closed, the running bar does not work to save energy. When it gets light, the toppling will automatically be opened. In addition, our system also has a button system to control trampoline and flipping motor without depending the signal from sensor. In case the sensor has a poor identity or is damaged, you can see the trampoline motor. I will control it. Go forward. Go backward. the flipping motor. I will control it. Go forward. Go backward. That
Okay, that's all of my represent about the project. Hello.
yeah, I'm going to about discussion and conclusion for our product. About advantage of our project. First, satisfy the requirement of displaying temperature and humidity of agricultural products on LCD screen. Second, satisfy the requirement of automatic the process of opening and closing Japanese and flipping agricultural products. Finally, satisfy the motor control requirements without depending on sensor. However, about disadvantages, the product is not optimal in the arrangement of the sensors, wiring, Arduino microcontrollers, and supporting electronic components. About evolution for our product, in general, the product has met the proposed requirements, but the control and checkbox, the location of the sensors, and the wiring have not yet been designed because project in standard subject, sensor and actuators. So this disadvantage can be acceptable. About direction of product development. First, in the project of the leximeters, machining more firmly than mechanical systems with high-strength materials. Design energy box contains microcontroller, SD, power supply switch, place sensors, and wiring properly and clean. Second, practical implementation in the process of drying agricultural products are famous. Still the same product development direction for the project in the next semesters. In addition, it is necessary to choose sensors with negligible errors with minor damage when next outdoor. And this is the final slide for our team project presentation. Thanks for listening.